Good morning, mathematicians. We're looking at our Section C checkpoint for this Unit 2. So for number 1, we're going to look at this diagram and we're going to write an expression and then we're going to find the area. So that means we'll utilize our expression to actually get to our answer. Notice there's really two tasks here. Write an expression and find the area. So let's start off with number 1. What we need to ask ourselves is, what factors do we see being multiplied together? So first of all, I can notice that I have one whole here. But I don't just have one whole. In my columns, I have one whole, two holes, three holes, four holes, and five holes. So in the columns that I'm seeing, I see 5 holes. Now let's ask ourselves in the rows, what do we see? If this line right here represents 1, as we're being told, we actually have 1/3, right? Because we have one row out of 3 rows that have shading. So in the rows, we're seeing 1/3. So to build our expression, we are going to write what we are seeing, which is 5 times 1/3, or we can say 1/3 times 5. Those are both expressing the same value. Kind of hard with my stylus to write perfectly, but I want to make sure I write that operation symbol very clear for you. Okay, so now we are seeing the first task we were given, write an expression, and we've done that here. You don't have to have both of those. Remember, boys and girls, you could just have this or this. Those both express the same thing. Now we need to give the actual area that we're seeing. Well, how many rectangles have shading in our diagram? We have 1, 2, 3, 4, 5 that have shading. So we are going to write in our area that we have 5 as our numerator. And once again, we're going to ask, what was our whole set to be? How many rectangles make up one whole? Well, that would be, there's 3, right? So our denominator of our area is going to be 3. We know that 5 times 1/3 equals 5/3. So we can complete our expression to find our answer, or we can also think about how many shaded parts we have being our numerator, and then how many parts are in one whole as our denominator. The last thing we do have to make sure that we do, since this is area, we've got to report it correctly. So we are going to write that it's 5/3 what? Well, it's 5/3 square units. And that is now our answer for number 1. Let's go down and let's answer number 1B. We've answered number 1A. Let's answer number 1B. Well, first of all, once again, let's think to ourselves, if this represents 1, how many holes do I actually have? How many columns do I have? Well, there are 3 columns. So one of my factors is going to be 3. So I'm going to go ahead and write that. I have 3 as one of my factors. Now, when I take a look at my rows, how many rows do I have? Well, I know that this entire thing represents 1 hole, but I don't have that much shaded. I actually have 2 shaded out of 4. So we could write that as 2/4, or you could also write it as 1/2, because we know that those are 2 equivalent fractions. We have a half that is shaded, or 2/4 that is shaded when you are thinking about it horizontally or in rows. So we can write our answer in multiple ways here. For our multiplication expression, I can write that I have 3 times 2/4, or I could write that I have 2/4 times 3, or if you want to go with that idea of 1/2, you could say that you have 3 times 1/2, or that you have 1/2 times 3. Remember, boys and girls, you do not have to have all of these. You have to have one of these. But it is good for our brain to stop and consider the multiple ways that we can express that same thing. Now, what is 3 times 1/3? If I have 3, 1, not 3 times 1/3, what is 3 times 1/2? If I have 3 1/2 pieces, what I have is, certainly think about this, I have 3 halves. right? So that is one way that you can give your answer. For number 1B, you can say that you have 3 halves. That is true. Another way that we could say our answer for number 1A is we could say that we have 6/4, right? Because if I'm looking at each of these shaded parts, how many shaded parts do I have? Well, I have 1, 2, 3, 4, 5, 6. That's my numerator. And then how many holes is, how many parts does a hole have? Well, it has 4. And so certainly that could be where we get that idea of 4. Now the thing is, no matter how we report it, we must say that we have, for instance, 3 half square units. But we could also report it as 6 half square unit, or 6/4 square units. And if we go ahead and turn these into holes, which some of us are really getting good at doing, if I know that 4 of these make 1 hole, then I can say I have 1 hole and then I have 2/4 of another hole. So we could also report it as 1 2/4, or 1 1/2 square units. So I have 1 2/4 square units, and my last one I'm going to write is 1 1/2, and I'm going to use shorthand here. If I do SQ, that means square, and U for units. All right, boys and girls, those are your answer options for the area of 2B. You do not have to write all of them, but you should have one of those. Let's go down to this next one we are looking at, which is C. With C, we're going to ask ourselves first, where do I see the columns? I see 1 hole here, but I actually have 2, 3, 4 holes. So in my columns, I see 4 holes. Now let's take a look at our rows. I see 1 hole here. This would be another hole, but I don't have all of that. So instead, I could say that I have 1 2/3 of another hole, or more likely, you might think of it as 1, 2, 3, 4, 5. 1. Let me see here why this is not highlighting for me. Okay, I've got 1, 2, 3, 4, 5. So I could express this as 5. And then my denominator is set to be, there are 3 pieces in a whole. So we could also express it as that, 5/3. So let's go ahead and let's start with our expressions. I'm going to kind of write these down below. I can say that I have 5/3 times 4, or I could say I have 4 times 5/3. Alternatively, if you thought about it as 1 2/3, you could say that you have 1 2/3 times 4, or you could say that you have 4 times 1 2/3. So these are the multiplication expressions that you could write. Once again, you should see your answer reflected in one of those, but you don't have to record all of those, right? But you should see your answer in one of those. Now we actually need to go in and give our area. Where do we see the area here? Well, let's start with thinking about how many holes we have. We already said we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we could say that we have 20 over how many holes, or how many pieces are in one hole? Well, there are 3 pieces in a hole, right? So we do have 20/3 square units. I could write that as my answer. Or if you want to go on in and circle your holes and think about what 20/3 is as a mixed number, I see 1 here, 2, 3, 4. Then I see 5, 6, and 2/3 left over, right? So we could also report this as a mixed number. We could say that we have 6 2/3, and again, that would be square units. Okay, so we thought about our number 1 in a couple different ways. We've thought about our expressions in the area, but we do have one more question here, and we're going to be representing and solving this problem that certainly is given to us in words. We're going to go ahead, we're going to read it, we're going to write it, and evaluate a numerical expression that represents a whole number times a fraction, right? So here we have a bottle holds 2 liters of water. Claire drank 3/5 of the bottle of water. How many liters of water is that? Explain or show your reasoning. So as we read this, and of course we should read it multiple times to make sure that we're clearly understanding our question, and then you go back and you zero in on your numbers. We have 2 liters of water, and she didn't drink all of it. She drank 3/5 of the bottle of water. So first of all, we need to think, how could we show that as an expression? Well, I could show it as an expression. By thinking, okay, really, this is asking me what is 3/5 of 2? Because she didn't drink all of the 2 liters of water. She drank 3/5 of the 2 liters of water. Now, the same pattern that we have found to be true is going to help us here, where we can multiply our numerator times our whole number. And when I do that, I'm going to arrive at an answer of 3 times 2, which is 6. And my denominator is going to say the same. She drank 6/5 liters. Now, I know that, and we need to explain our reasoning, so we can go ahead and say that here. We can say that we understand there are 2 liters of water. Notice I'm restating, I'm using the context of the word problem. And now let's think about that 3/5, and she had 3/5 of the water. So that is 3/5 of 2, or we can say 3/5 times 2. And we're also going to write what that equals by saying, or 6/5 liters. Okay, so that completes our number 1, where we have thought about it in the context of a word problem. Last but not least, as we come on down to number 3, notice now we're going to find the value of these expressions, and we do not have any word context. Instead, we are just going to proceed with solving. Let's use our idea of multiplying our whole number times our numerator to help us solve this number 3a. 1 times 10 is going to be 10, and our denominator will stay the same. So our answer for number 1 is going to be 10/5. Or we could ask ourselves, well, how many times will 5 go into 10? Well, that will go in exactly 2 times. So our answer can be 10/5. Our answer can be 2 wholes, or really anything that's equivalent to that, boys and girls. Okay, let's go ahead to number B. First of all, remember, boys and girls, we can pull apart our whole number 5. So we can do 4 times 5, and then we can do our proper fraction 4 times 2/3. So when I do it that way, I'm going to have 4 times 5, and then I'm going to have my 4 times 2/3, right? Well, I know that 4 times 5 is 20, and I know that 4 times 2 is going to give me a numerator of 8 and a denominator of 3. Now, I'm going to go ahead and further simplify that 8/3. I'm going to ask myself, well, how many times can 3 go into 8, right? Well, 3 can go into 8 2 times. And how many are left over? 2. So I know that 8 and 8/3 is equal to 2 and 2/3. So I'm going to have 20 plus 2 and 2/3. So my answer here is going to be 22. Oops. Let me erase here, make my answer a little clearer. My answer here, when I join my 20, join my 20 and my 2, I get an answer of 22. And then I have this 2/3 stuck to the side. So my answer here is going to be 22 and 2/3. Okay, so that is one great way that we can give our answer for number 2. Or I should say 3B. Okay, let's go ahead to our very last problem here. For our very last problem here, we have 5 times 13/4. So the first thing I'm going to do is I'm going to multiply my 13 times 5, and then I'll keep my denominator the same. So I'm going to have 13 times 5, and I'm going to keep my denominator of 4. Well, let's think about this. I can do 10 times 5, and then I can add that to 3 times 5 to be able to do it really with mental math. I normally wouldn't write that out, but I do want to kind of explain my thinking to be able to do it mentally. So here, I'm going to have 50. Here, let me erase this. I didn't write that down correctly, boys and girls. Let me try that again. I'm going to have 3 times 5. And 3 times 5 is 15. So I'm going to have 50 plus 15. That's going to give me 65/4. And we can leave it just like that as 65/4. We don't have to simplify these to get the correct answer for us, which is a great thing for these problems to solve. So we can keep this as 65/4. Now, if you're someone who's really wanting to take that to a mixed number, remember that you can ask yourself, well, how many times can 4 go into 65? Well, first of all, I could get 10 groups of 4, and that would use up 40 of those, right? I would have 25 left over. How many times can 4 go into 25? Well, it can go in 6 times, and that's going to use up 24 of these. There's going to be 1 left over, which is my remainder. So my answer here can also be this 10 plus 6, which is 16, and then I'm going to have 1/4 left over. So you could simplify that to a mixed number. You do not have to. There is nothing more or less correct about either of those. They sit in the same place of a number line, but I did want you to see that so that you could correct your answer or check your answer if you turned it into a mixed number. Boys and girls, that finishes out this particular checkpoint.